So we're going to go through and do some practice problems. These are some really fun problems. I enjoyed writing them. I hope that you enjoyed doing them. And they really have a lot of beautiful ideas. And if we understand what's in here, we'll be in great shape for the exam. Of course, we can never predict exactly what's on the exam. And so you should always study it. The more problems you do, the better you'll be. So let's work on these problems. We have 6 multiple choice, 4 long answers. It's going to be great. Here we go. Number 1. Which of the following corresponds with the 3-dimensional solid described in cylindrical coordinates by 0 less than or equal to 1 minus r, less than or equal to z, less than or equal to 2? And there's this parenthetical comment, shading indicates portions of the solid which have been removed. Now, of course, we see cylindrical coordinates, so that's a clue that we should put on our cylindrical coordinates hat. And as we look at the formula that we see here, we say, there's something missing, right? Because cylindrical coordinates has what? Has r and z and theta. There's no theta involved. So what does that tell us? Well, if we don't see a theta, what that tells us is that we're going to get the same regardless of our choice of theta. So no theta, this implies rotational symmetry. And so in particular, we say, hey, we're going to be symmetric about the z-axis. All right, good. Well, how do we proceed? What I like to do is once I see that there's no theta involved, I like to work in what I like to call the RZ plane. And here's sort of how you can think of it. You say what we're going to do is we're going to look at sort of a half plane. We're going to say what's happening in this half plane, and then we'll spin it. All right, so that's our goal. That's our goal. What's happening there? So with that in mind, let's talk about our pieces that we have. Well, when I say our pieces, I'm talking about there's 3 things together. Each inequality is describing sort of a limitation on our region. We have 3 inequalities, so we'll get to do this 3 times. So if we start with our first inequality, 0 is less than or equal to 1 minus r. Well, okay, that's probably an easier way to say r is less than or equal to 1. Now, what does that tell us? In terms of the RZ plane, and so when we talk about RZ plane, it's our half plane here. So here's r, and here's z. We're saying, look, we're going to go out to r equals 1. So that's this line here, r equals 1. And we have to be less than or equal to that. And so if we just shade that in, it's this strip. Okay, so that's our first constraint. We'll get more right now. We don't know enough to make any solid conclusions. That's okay. Ha, solid. It's a pun. Okay, now what's next? Let's go to our next inequality. Okay, so this one is probably going to be the interesting one. We have 1 minus r less than or equal to z. Now, the reason I say this will be the interesting one is it involves both r and z. And if we do a quick sketch here, what do we have? Well, in terms of r and z, this would be a line. So you can think of r as being like x and z as being like y. So if you just say, let's do the equality part, it would look like y equals 1 minus x. You're like, oh, I know that. That's a line that would start here at 1 and then just have slope down. Say, okay, so that's that. Now, which side of the line are we on? That's going to be important. And the answer is, well, we need to be above it, right? So it needs to be above 1 minus r. So we're on the top side. All right, so we're up here. Okay, so that's that condition. Now, one more. All right, so our last one is z is less than or equal to 2. Okay, so z less than or equal to 2. Again, we go and we sketch in our RZ plane. And we say, okay, there's R, there's Z. We're up here at 2. And so we have Z equals 2. That's this line. And we have to be less than or equal to that. So that says, whoops, wrong one. That says we're going to be below. So we're down here. All right. So those are our 3 inequalities. And so now if we put all of those together, we're going to see a single picture emerge. So what's our overlap? So now combine. And we're going to get the pieces. All right. So R, Z. We have our 1 minus R. We have our R equals 1. And we have our Z equals 2. And so when we lay them on top of each other, we get this shape. Kind of like the state of Nevada. All right. So that's our RZ picture. Now remember, what do? We spin. And so spin this around. And what shape are we going to see emerge? Well, we're going to see the following. What do we get? Well, it looks like a cylinder, but we take out this cone at the bottom. So we're looking for a cylinder with a cone removed at the bottom. And that's not it. Cylinder with a cone at the top. This has cylinder, cone at top and bottom. Those aren't it. But, of course, we skipped over the right answer. We could jump straight to that. B. Okay. And there we go. Woohoo! Nice! Oh, what a fun problem. We get to express kind of our artistic skills. Oh yeah. All right, well, okay, got to keep moving, right? Lots of problems to do. Number 2. We're in spherical coordinates. And it says, if you fix the angles theta and phi, this corresponds to a ray coming out of the origin. And so this is true, right? So when you think of spherical coordinates, what's going on? Well, what's happening is you have a combination of 3 things. Theta, phi, rho. Theta and phi are saying, here's the direction you should go, and rho is a distance. And so you say, oh, so you have this ray coming out of the origin. Phi, that was the specification of how far off from the positive z-axis you go. And then what happens is downstairs, your theta, that's the specification of how much you move in the xy plane, how much you've spun. And so, yeah, so if you fix theta and phi, you get a ray. All right, now, find cosine alpha, where alpha is the angle between the ray with, we have theta equals 3 pi halves, phi equals pi over 6, and the ray with theta equals 2 pi thirds, and phi equals pi over 4. Okay, now before we read the hint, there's already a hint. There's a big hint here. And it comes not in the word spherical coordinates, although, of course, that's going to be important, so we're going to mark that. But the really big hint here is it says cosine alpha. So that's a monster-sized hint. And you might say, well, how is that a hint? Well, the thing is that when you see cosine alpha, you should say, hey, cosine alpha, you should think dot product, right? That's what you tie cosine alpha to. Because there's a nice little formula. U dot V is magnitude of U, magnitude of V, cosine alpha. And in general, if you are looking for angles between things, dot product is the way to go. All right. So we know we're like, okay, we have dot product on our mind, but you're probably thinking like, well, wait a second, these are rays and not vectors. How do we get unit vectors? There's a hint. You can make unit vectors for the direction of these rays. Oh, that's going to be really good. By finding the points corresponding with rho equals 1. Right. Okay, so here's the idea. See, if I'm coming out of the origin, if I go out to a distance where rho equals 1, that has length 1, because rho is distance. And this point, I just turn it into a vector, and that's the vector pointing in the direction I need. Nice. All right, so we have an idea. We need to make the points corresponding with rho equals 1 and these combinations of theta and phi. If we do that, we turn them into vectors, dot product, life is good. All right, plan in place. But how do we actually do it? Well, we have some formulas. Of course, there's always formulas. And we have things like z is rho cosine phi, and r is rho sine phi. But we also have x is r cosine theta, and y is r sine theta. So all of these we have on our fingertips in our formula sheet. And we can combine these to get things which are there, but not quite on the formula sheet, but ready for us to combine, right? Because we see r and we see r. So we get that x is rho sine phi cosine theta, and y, that's rho sine phi sine theta. So there's our x, y, z. Okay, so here we go. In particular, a generic point, which will turn into a vector, which has rho equals 1. All right, so if rho equals 1 will be the x, I'm just going to write this down, sine phi cosine theta, then it's sine phi sine theta, and cosine phi. So we now need to just plug these in. All right, well, let's do it. If we do theta is 3/2 pi, and phi is pi over 6. Well, what do we get? Well, we'll just write it down. Sine pi over 6, cosine of, 3/2 pi, comma, sine pi over 6, sine 3/2 pi, comma, and then cosine of pi over 6. Now, some things we can look up, other things we can figure out. Sine pi over 6, we can look that up. It's on our formula sheet. So that's a half. Cosine pi over 6, root 3 over 2. Now, 3 pi over 2, if we just think of our unit circle, where is 3 pi over 2? Well, 3 pi over 2 is going to be down here at the bottom. So this is 3 pi over 2. And what do we see? Well, the x-coordinate is 0, so that says that's a 0, and the y-coordinate is a -1. Okay, so that gets us those entries. And so what do we get? All together, we get this is equal to 0, comma, -1/2, comma, square root of 3/2. All right, so that's the first one. Okay, so to emphasize, that's the one we just did. Now, we're going to do the same thing again, but with the other one. All right, so let's do this one. Okay, so we have theta equals 2/3 pi, and phi equals pi over 4. Okay, so we're going to go sine of phi, cosine theta, comma, sine phi, sine theta, comma, cosine phi. All right, now we can look some of these up, right? The pi over 4, that's on our sheet. So that's root 2 over 2, root 2 over 2, root 2 over 2. So what about 2 pi thirds? Now that's not exactly on our table, but if you think about where things are, so pi over 3, that's over here. 2 pi over 3, by symmetry, right, it's like pi, but then go back, pi over 3. So that's over here. So what's true? Well, it has the same y value, but the x value is a different sign. So since we can look up sine pi over 3, we can say, aha, sine of 2 pi over 3, it's the same thing as just sine pi over 3. So that's a root 3 over 2. Cosine 2 pi over 3 would be negative of cosine of pi over 3. So that's minus a half. Okay, so what does that give us? Well, if we put this together, we get minus square root of 2 over 4, comma, square root of 6 over 4, comma, square root of 2 over 2. All right, so we're almost there, right? I know you're like, are we? We've been doing this a while. Yes, we're almost there, right? Because these are our 2 unit vectors. And we know the dot product, well, the magnitude of u, magnitude of v, 1, 1, cosine alpha. So now the answer is, what's the dot product? So once we found our dot product, we're done. We finished. Life is good. Okay, so all that's left is the dot product. So here we go. 0 minus 1/2 square root of 3/2 dot minus square root of 2 over 4 square root of 6 over 4 comma square root of 2 over 2. So that's going to be 0 times, well, as soon as you get 0 times anything, minus square root of 6 over 8, and then plus square root of 6 over 4. Well, square root of 6 over 4 is like 2 square root of 6 over 8. So if you put those together, we get square root of 6 over 8. So that's the answer, and that's on our list. So the answer is D, square root of 6 over 8. Whew! That was a good one. There's a lot of fun ideas here. And, how do you find angle between things? How do you do points in spherical coordinates? So good problem. I like this one. I like this one. All right. Well, we have other ones that we like too. We got to make sure we give all our problems love. Oh my goodness. I got so excited on the last problem. A little bit came through, but that's all right. Find the distance from the point 6, 1, 2 to the line given in parametric form by x equals 2 minus 8t, y equals 5 plus 4t, and z equals t minus 1, and we have 1, 2, 3, 4, 5. Okay, so how do we go about doing this? Well, first thing, let's write the line down, and I'm going to write them right on top of each other because I feel that helps me see what's going on. 2 minus 8t, y, 5 plus 4t, and z. Now notice they did something a little bit sneaky here. They wrote it as t minus 1. So I'm going to write it as minus 1 plus t. And written in this form, we can do 2 things very quickly. We can identify point, and we can identify direction vector. And how do we do that? Well, the point, that's your constants. So there's the point. And then direction vector, that's what's in front of your t's. So that's this piece here. And all right. So we're going to make some notes here. We have our point is 2, 5, negative 1. And our vector is minus 8, 4, 1. And got to use those sharp corners. All right. Now, with that, how do you find the distance from a point to a line? The answer is we look up the formula. And if you look at the formula, it looks something like this. There's a little dot and a little line. That's point line. That says that's going to be equal to the magnitude of PQ cross U over magnitude of U. Now, what does all of this mean? Well, here's the picture. We have a line, we have a point, we're going to think of Q as the point we're trying to find the distance from, P as a point on the line, and then U is the direction vector of the line. And it says, if you want to find your distance, well, what do? Is you say, find this length, not find this length, find this vector from a point P to the point Q, then do the cross product, find the magnitude, divide by the magnitude of the direction vector. Now, this point here, point on the line, that's our P. This other point, Q, is, so the point off the line, that's 612, that's equal to Q. Now, by the way, if you switch the roles of P and Q, you get the same answer. So no worries at all. So what do we need to do? We need to find this vector. All right, so here we go. The vector P to Q is, and remember, how do we find vectors? We say, how much did we change? Well, if I'm going from P to Q, I go 2 to 6. That's a 4. 5 to 1. That's a -4. -1 to 2. That's a 3. So we have 4, -4, 3. And double check, right? Make sure you're consistent. Right? You don't want to be like, oh, I went 2 to 6, 4, 1 to 5, 4. No. That'll mess everything up. You got to get the signs right. You got to be consistent. Where did you end minus where did you start? And just go through. Okay, now with this, we're going to do the cross product. A cross product, I'll tell you, I'll be honest with you, like they always anticipate at some point there will be a cross product on the exam. Maybe it's finding a normal vector, maybe it's like a problem of point to line, maybe it's a problem involving area of a parallelogram or something like that. But you should expect to do a cross product. So know how to do your cross products. So how do we do it? Well, so you can say PQ cross U. Set up our 3 by 3 matrix, I, J, K. Right, that's the first row. Then the vector PQ, 4, -4, 3. And then the vector U, which is this vector, right? This is U, -8, 4, 1. And do your cross product however you're comfortable. Some people do cofactor expansion. Other people do diagonals. However you do it, as long as you get the right answer, we're all good. So I like to do diagonals. I times -4 times 1, -4i. J times 3 times -8, -24j. K times 4 times 4, 16k. All right, other direction. -8 -4k, that's 32k. I'm going to subtract 32k. 4, 3i, that's 12. Going to subtract. 1, 4j, that's 4j. Going to subtract. And so if you put it together, we get -16, comma, -28. And what do we have? -16 again. Okay, all right. Well, I like to pull out common factors because oftentimes it makes computations easier. And 16 and 28 and 16 all have factors of 4. We can pull out a -4. -4, 4, 7, 4. Now, I always get nervous. And so I calm my nerves by checking my answer. How do we check cross products? We check perpendicular. So I'm going to compare it to U. Do a quick dot product. -32 plus 28 plus 4. So we're doing a dot product. What do we want? 0. What did we get? 0. Okay, how about here? 16 minus 28 plus 12. 0. Again. Woohoo! Yes. Okay. So if you get 0 on both times, that's a sign. 99% of the time, you got the right dot product. Okay, so almost there. Almost there. So here we go. We have to plug it into our formula. So we have the magnitude of PQ cross u over magnitude of u. So that's the magnitude of negative 4 times 474 over the magnitude of minus 841. Okay. Now, the nice thing is, because we have that scaling factor, we can just pull it out of the magnitude, and it comes out as a 4. Take the absolute value of negative 4. Then we take this magnitude of this, which is 16 plus 49 plus 16, right? You just square each entry and add. Downstairs, square root 64, negative 8 squared, plus 16, plus 1. And 16 plus 16 is 32. 32 plus 49 is 81. Well, downstairs, 64 plus 16 is 80, plus 1 is 81. Now those become 9s, but it doesn't really matter what they become because they cancel. So we're left with a 4. That's one of our options. Ah, beautiful. It worked out so well this time. Nice. All right, good. Well, as much as we'd like to enjoy it, right, we have to keep moving. So, number 4. Which of the following formulas given in cylindrical coordinates is a hyperboloid of one sheet? So we have to know our quadric surfaces. Now, a hyperboloid of one sheet, just to remind ourselves, that's the one that looks like this. It's sort of like an hourglass type thing. All right, so that's what we're looking for. Now, what is the generic formula for that? Well, we want something that looks like x squared plus y squared minus z squared equals 1. Because what's really happening is it's x squared plus y squared is 1 plus z squared. And so for every value of z, you're going to have some positive radius, right? So you're always going to get an ellipse of some sort, and it gets a bigger ellipse as you go up and down. Okay, so that's sort of the generic formula. And we say, okay, well, what are we getting? Well, notice when we have r squared, that becomes x squared plus y squared. So here we have x squared plus y squared plus z squared equals 1. Nope, that's not a hyperboloid. That's an ellipsoid. Okay, so that's not going to work. R squared cosine 2 theta minus z equals 1. Now, we already can tell this is not going to work because we see the z. Now, when you see something where one of the terms has a z involved, what that indicates is paraboloid. And so we say, I see a z, this is a paraboloid of some sort. With a little bit of work, this is not our goal here. It turns out you can show this is a hyperbolic paraboloid. But we definitely know paraboloid, and we are not looking for paraboloids. We're looking for hyperboloids. Same thing is going on with c, right? What do you see? You see a z, and you say, oh, z is x squared plus y squared plus 1, right? Because that's what's going on here. And you say, okay, so this here, this is an elliptic paraboloid. All right, well, not what we're looking for. How about this one? Z squared minus r squared equals 1. Now, what's that going to do? If we look at z squared minus r squared equals 1, well, that's like z squared minus x squared minus y squared equals 1. Or, this is x squared plus y squared, right, is equal to z squared minus 1. Now, notice what happens if you plug in z equals 0. You get x squared plus y squared equals minus 1. That's not going to happen. So it's like completely missing the plane, the xy plane. So this is a hyperboloid, but the wrong kind. This is your hyperboloid of 2 sheets. And we say, okay, so that's not the one we're after. We wanted 1 sheet. So we already have gone to the point where the answer has to be E, but let's check it out. Let's check it out. What do you see there? Well, r squared is x squared plus y squared. And what do we see? Well, we see x squared plus y squared minus z squared equals 1. That's the one we want. So that is the hyperboloid of 1 sheet. we're good to go. All right, so quadric surfaces aren't too bad if you're familiar with the forms. Remember, when in doubt, take slices, and that'll help you figure out what's going on. All right, number 5. Find the value t where the tangent line to the parametric curve r of t is t cubed plus 2t, comma, minus 2t squared, comma, t squared plus 7t does not, okay, and man, they're really emphasizing, does not intersect the plane 2x plus 7y plus 2z equals 8. In other words, the line and plane are parallel. So the picture that we have in our mind is we have this plane, and then we have this line that's off the plane but running parallel to it. Okay, so how do we figure this out? Now here's sort of the key. What's going to happen? Notice that this direction, now that's the direction of the line, but direction is attached to a vector. Vectors are not attached to location, so we could move that direction down, and in particular, the direction of the line has to be a direction in the plane. Now we're like, oh, that sounds helpful, because whenever we think of plane, like our go-to tool with planes, you always are like, there's a plane, pull out normal vector, right? So given that we have that, hey, the direction vector of the line has to be a direction in the plane, and that tells us that the normal vector has to be perpendicular to that direction vector. And now we're like, perfect. So we have our plane 2x plus 7y plus 2z equals 8. By reading off the coefficients in front of the x, y, z term, we get our normal. So our normal is 2, 7, 2. Right? You just read off the coefficients. Now, our direction of our tangent line, so tangent line direction, will be what? Well, that comes from looking at the derivative. So we say, okay, so we're direction of tangent line. All right. Normally when we're doing a test, we don't make so many notes here. I'm going to point out, you may feel like, oh, Steve's going really slow. I'm also making a lot of notes. So don't worry. You will go faster. And you're young. You have young, healthy minds. So you look at r prime of t. All right, so that would be 3t squared plus 2. Okay, that's that, comma, minus 4t, comma, 2t plus 7. All right. So now we took it derivative entry by entry. These two vectors, the normal and r prime, these need to be perpendicular. So these are perpendicular to each other. How do we know if two things are perpendicular? Two things are perpendicular if the dot product is 0. So this is going to set up an equation. So in particular, we have that 0 is going to equal n dot r prime of t. So now we just do our dot product. So that's going to be 2 times 3t squared plus 2 plus 7 times minus 4t plus 2 times 2t plus 7. All right, and this gets us to a single equation, one equation and one variable. That's a quadratic, that's no problem. Let's expand and gather. So 6t squared plus 4 minus 28t, 4t plus 14, right? Be careful. Make sure your parentheses game is, in good form so that you distribute to all the terms. Okay, and we gather. We get 6t squared minus 28 plus 4 would make minus 24t, and 4 plus 14 would make an 18. Okay, well, those all have factors of 6. So 6 times t squared minus 4t plus 3. Okay, we're feeling pretty good. We're feeling pretty good. And that factors as t minus 1 times t minus 3. And, that equals 0. And so we get our answer, t equals 1 or t equals 3. And we're like, yes! And wait a second, t equals 1 or t equals 3. Okay, so we know it's not 2, 4, 5. Hold on. I thought multiple choice couldn't have multiple correct answers. Is something wrong here? Okay, now, there is a possibility. Now, it's not a possibility that there's 2 correct answers. There's a subtlety here. What did we say? We want to make sure we find the line does not intersect the plane. And we drew this picture, but of course there is something else that could happen, which is, versus the line is in the plane. So this is the line out of the plane. And here we have the line in the plane. We cannot distinguish between these 2 cases right now, right? This only thing it tells us is that, oh, hey, the direction is going to be such that it's a direction that matches the direction in the plane. So I think here's what's happening. One of these 2 is going to be a line in the plane. One of them is going to be a line out of the plane. So how do we figure it out? How do we break the tie? Well, we just pick a point. So now you go in, you say, well, let's plug in. So we have 2 cases. We just need to figure out what's happening. T equals 1. So we have, what is r of 1? Well, plug in 1, and we're going to get 3 minus 2, 8. Now, that's secretly a point, even though it's a vector. And now we're going to test it. 2 times 3 plus 7 times negative 2 plus 2 times 8. That's 6 minus 14 plus 16. That's 22 minus 14. That's 8. This is in the plane. Okay, so that's like, it can't be A, because we intersect the plane. We intersect the plane in all the points of the line. So the whole line is in the plane. So that's why it's not A. So by process of elimination, we now know the answer is C. If you want to feel extra confident, we can plug in 3. And what do we get? Well, R of 3. Well, we get 27 plus 6, which makes 33, minus 2 times 3 squared. So that's minus 18. And then 9 plus 21, which is 30. Again, we'll do our plugging it into the plane. So that's 2 times 33. We don't have to do this. We already know that the answer is C, but I'm just going to do it just to convince you. And 2 times 30. Okay, so that's 66. 7 times 18 is minus 126, right? We all know that. And plus 60. So we get 126 minus 126 equals 0. So this is not in plane. All right, so yeah, see, indeed, it does work. It is parallel to the plane, but it's not in the plane. So life is good. Oh, that was a subtle one. That's kind of tricky, Steve. Oh, you're up to your old tricks, Steve. I'm on to you. I'm on to you. No. It's okay. We put these on the practice exams. The ones on the real exams, they're always more fun. All right, on to number 6. We're halfway done. We finished 5 problems. For t greater than or equal to 0, a particle which is moving has a sub t is 3t squared minus 3, and a sub n is 6t. Given that the speed of the particle at time t equals 0 is 2, then how far will the particle travel from t equals 0 to t equals 2? Now, you might think, oh, we have a sub t and a sub n. So we can find a, right? We can find acceleration? No, we can't find acceleration. We could find the magnitude of acceleration. because there is a useful formula. So what are some formulas that might be relevant? Well, we have the magnitude of r double prime equals a sub t squared plus a sub n squared. And so you say, oh, we can find magnitude of acceleration. Will that help us? It turns out, no. It's kind of weird. It feels like this is the right formula, but it's not going to be the one that helps us. There's another formula right next to this one, and it says, hey, you know, a sub t, that's the derivative of magnitude of r prime. That's the one we're going to need. Why? Well, because what did we have? We say, oh, we have that 3t squared minus 3 is the derivative of the magnitude of r prime. So we say, oh, that helps us solve, right? So that tells us that the magnitude of r prime is t cubed minus 3t plus some constant c. Can we solve for our constant? Well, we are told that the speed, that's magnitude of r prime, at time 0 is 2. So we get that 2 is equal to 0 minus 0 plus c. So we say, aha, the speed is t cubed minus 3t plus 2. So that's our speed. Now, we're almost there. How far will the particle travel? Well, for that, we're after distance, right? So distance, that's equal to adding up from 0 to 2, the integral of r prime dt. So we magnitude r prime dt. So this is our a to b. So we're going 0 to 2, t cubed minus 3t plus 2 dt. Well, that's 1/4 t to the 4th minus 3/2 t squared plus 2t. And we evaluate 0 to 2. When you plug in 2, we get 1/4 times 16 minus 3/2 times 4 plus 2 times 2. And then when you plug in 0, you get 0 for everything. That's why we like 0. All right. Well, 1/4 times 16 is 4. 3/2 times 4, that's 6 minus 6. And then plus 4. 4 minus 6 plus 4 gives us a total of 2. So our answer is 2. Now, at this point, you're probably saying, wait a second, why did you give us a sub n? We didn't need it. You're right. We didn't need it. And so sometimes you might have things that you don't actually need. This happens a lot in real life, where you have a ton of information and you have to parse, well, wait, which information do I use? It does turn out that a sub n has been chosen in such a way that the magnitude of r double prime is nice. However, magnitude of r double prime does not get you magnitude of r prime. You know, it's that weird thing. And so it's like you have to make sure you understand how all these things relate. And so it's understanding, well, how do you get to magnitude of r prime? That's the key. And that's from a sub t. I'll make a little side comment here, because I think this is sort of an interesting idea. So we talk about a sub t and a sub n. Now, I talk about, it's the thing that's with motion and the thing that's perpendicular to motion. So a sub t, another way to think about it is the part of acceleration that affects speed. And I do apologize. I don't know if it's an A or an E for effect. I've never been able to figure that out. But the a sub t, that's the part of acceleration that affects speed. And that's shown in this equation. Right? It says, hey, if I want to understand how acceleration is changing speed, well, that's the a sub t. It's the derivative of speed. So you might say, well, what's a sub n? Well, this is the part of acceleration that affects direction. So in particular, it's not doing anything with your speed, but what it's trying to do is it's trying to pull you in some way. So a small a sub n says, well, try to keep going where you're going. A big a sub n says, you got to start swerving. And so since we're interested in speed, we only do need to look at a sub t. So this was a fun little one to understand how the pieces fit together. I do think that, I think it was D turns out to be a very tempting alternative answer. So if you got D, I totally get where you're coming from, but the answer is A. All right. Well, that's our last multiple choice. So that means it's time for the workouts. Woohoo! Workout, workout. Number 7. Find the formula for the largest sphere whose center is on the line x equals 7 minus 2t, y equals 17 minus 6t, z equals negative 6 plus t, and the sphere is between the parallel planes 2x minus 2y plus z equals 1, and 2x minus 2y plus z equals negative 17. Now we can see that they're parallel because these pieces are exactly the same. So they have the same normal vectors. All right. Well, what's the idea here? Well, the core idea is we have these two parallel planes. So we have plane 1, and then somehow translated plane 2. And we also have a line. Now, be careful with this line. All it's telling you is that there's this line, and that the center is on that line. And so we should expect it's doing something like this. And so that it might intersect the two planes, but then there's somewhere in between these two planes, right? It has to be between these two planes, right? Because it says between. There's this sphere, and so we're after the sphere. And well, my picture is kind of giving away where we want to go. So we have this biggest sphere here. Okay. Now the question is, what's that formula? And I got to tell you, they love asking sphere questions, partly because there was a whole lecture where that was the only thing we could do, was we could talk about spheres, because really what's going on with spheres is it deals with distance. All right, so how do we go about solving this? Well, the picture kind of gives it away, right? So, well, look, if I have the places where the line intersects the planes, where will the center be? Turns out it's going to be the midpoint, halfway in between. Say, okay, well, that's good. So all I need to do is just figure out where are my intersection points, take a midpoint. Now, there's a couple ways we can actually get there, but let's work on that first. So let's talk about intersections. So what do we get? We have a line. How do we find where a line intersects a plane? Well, what we do is we plug the line into the plane. So let's go ahead and start. So we're going to take 2x minus 2y plus z equals 1. So we carefully distribute, and we're going to get 14 minus 4t minus 34 plus 12t minus 6 plus t equals 1. And we'll gather. We have 12t plus t makes 13t. Subtract 4t, that makes 9t. Not the number 90, 9 times t. And we have a 14 minus 34 makes minus 20, and minus 6 more, well, that makes minus 26, and that equals 1. All right, well, from here, we can say, oh, now add 26. So I'm going to put a little line here, and we get 9t equals 27, or t equals 3. So let's say this is our top one here is minus 2x minus 2y plus z equals 1. And down here is 2x minus 2y plus z equals negative 17. So for the 1, it says you intersect at t equals 3. That's the time. Now, that's not a point, but it's the time. We'll get into the point in a moment. Okay, now, that's plane 1. What about plane 2? And you're like, oh my gosh, it's going to take forever. Well, actually, we can recycle, right? We're great at recycling. Because what's going to end up happening? Well, we'll get 2 times 7 minus 2t minus 2 times 17 minus 6t plus negative 6 plus t equals minus 17. But this whole left-hand side is the same. So it becomes 9t minus 26 equals negative 17. Or 9t equals, if you add 26 to both sides, 9, which says t equals 1. So we're like, aha, this intersection down here happens at t equals 1. Now, 2 approaches. Approach 1. We can plug in our points. So if we plug in and get our points, we get that at t equals 1, this would correspond to the point 5, right? 7 minus 2, comma, 17 minus 6, 11, and negative 6 plus 1, negative 5. Up here, plug in 3, 7 minus 6, 1, 17 minus 18, minus 1, and then negative 6 plus 3, it makes negative 3. And now, the midpoint. So, if you find the midpoint, what can you do? Well, you add and divide. So, the midpoint would be at 5 plus 1 is 6, divided by 2 is 3. 11 minus 1 is 10, divided by 2, 5. Minus 5 minus 3 is minus 8, divided by 2 is minus 4. And that gives you the center. We now have our center. So here is our center. But I'll point out an alternative. This is a fun thing. An alternative says, oh, I know at t equals 1 I hit plane 1. At t equals 3 I hit plane 2. Where's going to be the halfway point? Well, what's halfway between 1 and 3? Oh, that would also be at time 2, halfway between time 1 and time 3. Now, if you plug in 2, what do you get? 7 minus 4, 3. 17 minus 12, 5. Negative 6 plus 2, negative 4. So that could have also worked. Plugged in 2. Now, we're most of the way done with our formula for a sphere. Because what's the formula for a sphere look like? Well, it looks like the following. You have your x minus h squared plus y minus k squared plus z minus l squared equals r squared. And where HKL, this is your center. Well, we already found our center. So for us, that's 3, 5, negative 4. So we're almost done. We've got 3 of our 4 numbers. How do we get that last number? How do we get r? Well, so how do we get r? Good question. Good question. So here's what we're going to do. We're going to make an observation here. We say, look, r is the distance from our center. And so that's 3, 5, negative 4 to the plane. Now you might say, which one? It doesn't matter. It's going to be either plane. So let's pick one. Let's pick this one. It has smaller numbers. I like the one is easier to deal with. 2x minus 2y plus z equals 1, right? Because it's just it has to be a big sphere, right? So it's like we're going to blow it up until it's just barely touching. So that's the clue. It's the largest sphere. So it's just... So now we're like, oh, I need to know the formula from a distance from a point to a plane. We have such a formula. So the distance, here's the formula. it has in the formula sheet, there's a little dot, a little plane, and it says ax0 plus by0 plus cz0 minus d divided by the square root of a squared plus b squared plus c squared. Secretly, it comes from a dot product. But what's going on? X0, Y0, Z0, this is your point. That's up here. AX plus BY plus CZ equals D. This is your plane. So we now plug in this information. So our radius is going to be equal to, we take absolute value, and essentially what you're doing is you're plugging in the point here into this formula. So it's 2 times 3 minus 2 times 5 plus negative 4. And then you move this one across, subtract 1. And more or less, this is saying how far off are you? And then we're going to divide by the square root of, and then it's going to be a 2 squared plus a negative 2 squared plus 1 squared. All right, well, upstairs we get 6. We get 6 minus 10 minus 4 minus 1. Okay, so there's a lot of stuff going on there. Downstairs, we get square root of 4 plus 1. That's square root of 9. And, all right, so 6, this is minus 15. 6 minus 15 is 9. Remember, taking absolute values, that's important. Like distance is a positive number. We can't get a negative number. So we get 9 over 3, which says our radius is 3. Okay, so our final answer, right? Because it says find the formula. So our answer needs to be a formula. Make sure you answer the question in the way it was asked. So our final answer is x minus your y coordinate squared plus y minus your y coordinate squared plus z minus, and minus minus makes a plus, squared, so z plus 4 squared equals r squared, which will be 9. And there we go. There we go. All right, good. Whew, that was a fun one. Okay, number 8. All right, lots of words, but hopefully, sometimes I feel like many words usually means not much work. So don't get intimidated when you see lots of words. In one dimension, work is computed by finding the product of force and distance. So work is F times D. All right, I feel like we're doing physics. In higher dimensions, work is computed by finding the dot product of force and displacement. So work is F dot D. So, in higher dimensions, you add a dot. Nice. Okay. So, find the work done, given that the force measured in newtons was 11 minus 1 minus 5. Okay, so we have this part. That's our force, while the resulting displacement measured in meters was 3,1 and negative 4. Okay, that's that part. And then it says, of course, there's an extra direction. Include units in your final answer. Well, if they ever put that in as an instruction, we got to do that. Now, you might say, how do we do this? It's right there. It says, look, find the work. And work is F dot D. Okay, so we're going to take our F, 11 minus 1 minus 5, dot 3, 1 minus 4. So this is our F, and this is our D. So this gives us what? Well, 33, right? 11 times 3, minus 1 times 1, and plus 20. 33 minus 1 plus 20 makes 52. Now, is this our answer? I just put a box around it, right? Is this our answer? No. Why not? We didn't include units. Oh, yes, that's right. We needed to include units. What are the units? Well, force has units of newtons. displacement has units of meters, so it's 52 Newton meters. That is the answer. That's it. Part A. Oh, we should have put this one on the test. Well, hold on. There's a part B. So it says, find the portion of the force vector in part A that did not contribute to the work. So notice that these aren't parallel to each other. So they're sort of askew. And it's like, oh, okay. So some of the force was sort of helpful in moving it, and some of the force was not. So it even says it right here. That is, find the portion of the force vector which is perpendicular to the displacement vector. Okay, so the picture. What do we have here? Well, we have a displacement vector. So here's our displacement vector D. And then we have our force vector. And okay, so we'll draw that. Here's our force vector F. And now, what's going on? Well, what's going on is we can really split force into two parts. So one part is useful in moving, and one part is not, right? So this is the part we're after. So this is what we want. So that's the part of our force vector which does not contribute to work. It's perpendicular to our displacement vector. So how do we get there? Well, idea. This is the part of force that did contribute to work. What does that look like? That looks like the projection. So we say, well, let's start with this portion here. This is the projection of force onto displacement. So let's find that. Okay, so the projection of force onto displacement, the formula is F dot D over D dot D times D. Okay, that's just from the formula sheet, no surprises. And F dot D we already know. We did it in part A. So we get 52. Don't worry about units right now. D dot D. So here's the D, right? So this is, well, go ahead and mark these. So D dot D, that's 9 plus 1 plus 16. And then times our direction vector, 3, 1, negative 4. Okay, well, 9 plus 1 is 10, plus 16 makes 26. 52 over 26 is 2. So this is 2 times 3, 1, negative 4. And then we say, well, look, that's really 6 to negative 8. Now, what's the idea? Well, we have that if we take this projection, so 6 to negative 8, plus, this is what we want. So this is the part that's helpful for moving and doing the work. This is the part that's perpendicular. Then we get out the actual force, right? Because we added these two together gives us force, which is 11 minus 1 minus 5. So we say, aha, we can just subtract, right? Because we can do basic algebra with vectors. And so we're almost done. We just need to carry out this subtraction. So our answer is what? Well, we take 11, subtract 6 is 5. Minus 1 subtract 2 is minus 3. And then minus 5 minus minus 8 is a plus 3. So 5 minus 3 plus 3. And that's the part of force that did not contribute to the work. So that's, in some sense, you could say, is that wasted force? Yeah, that's actually a reasonable way to think about it. It's the wasted part of force. And but that's the answer. Ah, that's good. Whew, finally, one that doesn't take a whole page. Well, it takes half a page to write the problem. But okay, almost there. A few more to go. Number 9. Given that A of t is 12t squared minus 4, 12e to the 2t plus 6, and 2 minus cosine t, with v of 0 as 1, 2, 3, and r of 0 as 5 minus 2, 1, then find the position function r of t. So this is just saying, do you understand how all the pieces of motion fit together? So there's not a lot of surprises. So, for example, A of t is really r double prime of t. So that's 12t squared, excuse me, 12t squared minus 4, 12 e to the 2t plus 6, and 2 minus cosine of t. Now, we integrate once, right? Our goal is to get r. We have r double prime. So we're going to integrate twice. Well, if we're going to integrate twice, we have to first integrate once. So integration of acceleration gives velocity. That's r prime of t. And integrate term by term. So here, add 1, divide. So that would be 4t cubed minus 4t plus some constant a, comma. Here, don't forget to divide by the 2. That's essentially coming from the chain rule. So that would be 6 e to the 2t plus 6t plus a constant. And then 2t, and then integral of cosine is sine. So we'll have minus sine t. Pay attention, is it plus or minus? It can make a difference. So you want to make sure you're getting the right signs and everything. And plus a constant. Notice these are different constants, a, b, c. Now, we're told v of 0, that's 1, 2, 3. But we can also plug 0 in here. What do we get? We get a, because we get 0, 0, a. 6, e to the 0 is 1, so 6 plus b. And 0, 0, c. So say a, 6 plus b, c. And okay, so that tells us a equals 1. B is minus 4, right? Because 6 minus 4 is 2. And c equals 3. All right, so with all of that, put it back in. And now we have our r prime of t. Okay, so 4t cubed minus 4t plus 1. 6 e to the 2t plus 6t minus 4. And 2t minus sine of t plus 3. Well, that was an idea so nice. Let's do it twice, right? We integrated once, we got r prime. Integrate a second time, we'll get r. So our r of t is going to be, again, term by term, integral 4t cubed, t to the 4th. Integral 4t, 2t squared. And then plus t plus another constant, moving our way through the alphabet. All right, well, we'll get to find out a lot of letters. Integral 6 e to the 2t, 3 e to the 2t, because we're going to divide by 2. Integral 6t, 3t squared, minus 4t plus another constant. And integral of 2t is t squared. Integral of minus sine is a plus a cosine. Be careful. Integrals of sines and cosines I'm always really worried about because it's a little strange, right? And I say it's a little strange just because you're so used to derivative rules, and then like the integral rules, like the things flip around, and you're like, be careful, right? Now, that's not the answer because you have these constants. But that's okay, because what do we have? We have r of 0. So we're told, hey, r of 0, that is 5 minus 2, 1. Well, plug in 0. 0, 0, 0. D. 3, e to the 0 is 3. 0, 0, e. 0, cosine of 0 is 1. And then that's a 0. And then f. Okay, so what does that tell us? Well, d has to equal 5. 3 plus e is negative 2. So e is negative 5. And 1 plus f has to equal 1. So f is 0. And so we're ready to write down our answer. We just plug in d, e, and f. So r of t is t to the 4th minus 2t squared plus t plus 5, 3e to the 2t plus 3t squared minus 4t minus 5t squared plus cosine t plus 3t plus 0, which we don't need to write the plus 0, and done. Now, there's not a lot of surprises on this one, and in essence, it's just a matter of just carefully working through term by term. It's like a Calc 1 problem. We're just doing it 3 times, 1 for each entry, and so just be patient. You know, there's not hard integrals here. The problems are not to say, hey, let's give you hard integrals and see how you do. The problem here is to say, can you just carefully work it through? And oftentimes it's just copy errors. That's going to be your biggest challenge. So be patient. Give yourself time so that you'll have enough time. You can do it. You can do it. All right, that leaves us with one more problem. Okay, number 10. All right, for t greater than 0, a particle travels along the parametric curve. R of t is t squared minus 4t, comma 3t, comma 4t to the 3 halves. And we're asked, find a sub t of t and a sub n of t for this curve. And then part B, find curvature for this curve. All right, now the good news is there's a methodology here. We can do this. So we're not going to panic. We're going to use our formula sheet. So there's 3 formulas that are going to come into play from our formula sheet. One formula says, if you want a sub t, this is the derivative of the magnitude of r prime. So we're going to find magnitude of r prime, take the derivative, and we'll get a sub t. Then we're going to say, oh, if you look at the magnitude of r double prime squared, that's a sub t squared plus a sub n squared. And we can find that pretty straightforward. We'll have found a sub t, so then we get a sub n as a freebie. Just solve. And finally, curvature kappa, that's equal to a sub n over magnitude of r prime squared. So we just need to apply these 3 formulas, and we'll be in good shape. Now, it's not just applying the formulas. There's some extra computation that has to come into play, but let's do that. So we start, really, step 1 is heading towards that magnitude of r prime. So we have that r prime of t is 2t minus 4, 3. All right, here, bring down the 3 halves. 4 times 3 halves will be 6, t to the 1 half. Now, the hard part of many of these problems is figuring out how to figure out magnitude of r prime. And this is a time when you like cross your fingers and be like, okay, our teachers, they love us, right? They love us. And so in particular, we should expect nice things to happen because magnitude of r prime involves a square root. And that's why it's like, oh, it's going to get tricky here. So square the first term, square the second term, square the last term. And if we live a good, clean algebra life, good things should happen. So we start expanding. This will give us 4t squared. Your a squared, your 2ab. Don't forget your cross terms. And so that's going to be minus 16t. And then plus 16. We have a plus 9. All right, 3 squared. And here, 6 squared is 36. And t 1/2 squared is t. Notice here we're always assuming t is positive, so we're not going to worry about, oh, what if t is negative? Not a problem for us. We now put things together. What can we do? Well, we have the 4t squared. Minus 16 plus 36 is a 20t. 16 plus 9 makes 25. Now, if we're lucky, this will factor. Now notice there's no common terms right now, so we can't pull terms out. So this looks like a 2t squared at the start. This looks like a 5 squared at the end. Now the question is, does this look like a 2 times a 2t times a 5? Well, that would have to be 20t. That is what it is. Oh my gosh. Woohoo! Yes. Okay, so This is the square root of 2t plus 5 squared, or 2t plus 5. Okay. Good. Good. Whew. All right. On a side note, before we go into these computations, let's do r double prime of t. What does that give us? 2, 0, and 3t to the minus a half. All right. Now we're ready to finish the problem. And you're like, what? We barely started. Yeah, but all the pieces are ready for us. So here we go. A sub t is the derivative of 2t plus 5, which is 2. Okay, see, once we found magnitude of r prime, take the derivative. Now we say, okay, take the magnitude squared of r double prime. So we're going to do 2 squared plus 0 squared plus 3t to the minus 1/2 squared. Okay, so this is our magnitude of r double prime squared equals 2 squared. This is a sub t squared plus an squared. Now, what do we see? The 2 squareds cancel. That doesn't matter. The 0 squared's gone. So we say, aha, that tells us that a sub n, taking the square root of both sides, is 3t to the minus 1/2. Or we can write that as 3 over square root of t. And okay, great. Now we're done with part A. What about part B? Well, part B, as soon as you've done part A, it's a freebie. Once you understand the formula, so kappa, that's our 3 over square root of t, right? That's our a sub n over our magnitude of r prime squared, 2t plus 5 squared. Well, okay, just sort of clean this up. That's 3 over square root of t times 2t plus 5 squared. And that's it. That's the last piece. So know your formulas. But the nice thing is you don't have to memorize them. You just have to know how to use them. They're there for you to succeed. We want you to succeed. We want you to do well. Now you're probably looking at it and say, oh, Steve, you went a couple minutes over. I also went pretty slow and I rambled. This is doable. This one is meant to stretch you a little bit. I'm not going to kid and say, oh, this is a typical test. This is a bit on the harder end for some of these problems. But they're within your abilities. You're amazing. Keep studying. Keep practicing. You can do this. You can succeed. We believe in you, and we want all the best. All right, good luck, and I hope to see you on the other side. Bye.